Good evening. Thank you for being here in the midst of these challenging times. My name is Scout Meredith Best, and I am a Clark Forum Student Project Manager. On behalf of the Clark Forum for Contemporary Issues and the Departments of Anthropology, Archaeology, History, Environmental Studies, and the Food Studies program, I would like to enthusiastically welcome you to tonight's event, Unraveled Myths, the Green Revolution and the Gene Revolution. Technological advances in agriculture have developed significantly since the second half of the 20th century, allowing for better harvest, improved irrigations, and new varieties of crops. A key aspect of this development has centered around genetically modified organisms, known as GMOs. This process allows scientists to develop desirable traits in plants and has been met with both admiration and concern. On one hand, GMOs allow plants to provide bigger yields, be resistant to insects, and improve nutritional benefits. On the other, there has been significant public backlash against GMOs. While widely disproven to cause any physical harms to humans, ethical and environmental concerns remain. On a broader scale, the discussion surrounding GMOs is one which can be extended more widely to humans' interactions and reactions to the technology which have influence over so many aspects of our lives. So, without further ado, I would like to introduce tonight's speaker. Dr. Glenn Stone is an anthropologist who work centers on the politics and ecology of food and agriculture and agricultural biotechnology. He has completed fieldwork in India, Nigeria, and the Philippines, and is the author of one book and over 70 academic articles. He has been awarded fellowships by the National Endowment for the Humanities, the School for Advanced Research, and most recently the Simon Guggenheim Foundation. And he is currently professor of anthropology and environmental studies at Washington University in St. Louis. There will be a question and answer session immediately following the program, so please type your questions into the live chat next to this YouTube video at any times. Thank you for attending. Dr. Stone, you now may begin your presentation.
Thank you, Scout, very much. Thank you to the people at Dickinson for extending the invitation to me. I'm delighted to join you today by remote, although I would like to be there at Dickinson. I've never been to Dickinson. I was looking forward to coming and meeting folks there, but we'll have to make do. Let me share my screen here. So I'm going to be talking about the Green Revolution and the Gene Revolution, and we'll get around to talking about the Dude and Walter as well. It all sort of fits together. A lot of my work has been on a form of agricultural growth called intensification. This is the same thing that Maria Bruno, who's the head of the anthropology department there, has done a lot of good work on. And intensification, the way I write about it, is run by human labor. And if there's technological change, it's usually pretty simple, and it is based on locally available materials. So intensification has a long and distinguished history, and it has been practiced and continues to be practiced in a lot of parts of the third world or the global south, or smallholders or peasant farmers, or whatever we want to call them. There's a whole nother kind of agricultural growth, though, which is what I really want to talk about tonight, which is what I would call agricultural industrialization. And the key to industrialization is external technology. It's all about developing technologies that become inputs into agriculture. And we've been doing this for developing different sorts of external inputs for a long time. Industrialized agriculture, of course, is very widely practiced throughout most of the industrial world, or the global north. It's had a pretty checkered history, though, of moving into the global south, or moving into peasant farms. There have been untold numbers of projects and products and attempts to bring industrial agricultural technologies to peasant farms. And they've racked up a pretty sorry record. I used to work in Africa, and where I worked, there was the people that I was studying were surrounded by ruins of agricultural industrialization projects that just had failed. The last work that I did there was in the mid 90s with Robert Netting, who was a great writer on intensification. And this is him and me and our research assistants, and we were living in the tumble down ruins of an irrigation project in central Nigeria. So success stories of industrial agricultural technology being brought to peasant farms are pretty rare, but there are a few. And I want to talk tonight about two of the most important ones. One of them that happened about 50 years ago, and one of them that's still going on now. Both have been much discussed and much debated. Both took place in India, and both are, I'm convinced, completely misunderstood. And I think they're misunderstood for very important reasons. So what I want to do is introduce these two stories briefly, and then take a look at each one of them in a little bit more detail and explain what the myth is and why I think it's wrong. And then we'll step back for a few minutes and let the dude from the Coen brothers film, The Big Lebowski, lead us through some thinking out of why it is that we tend to get these things wrong. Okay, here's the first myth, the Green Revolution. And just for a brief introduction to it, I'm going to turn to screenwriter Aaron Sorkin. This, by the way, is my COVID lockdown guilty pleasure as I watch lots of reruns of The West Wing, an imaginary time when the country was run by people other than corrupt despots, and including the fictional president, Jed Bartlett. So in this episode of the Green Revolution, episode of The West Wing, you get a version of the Green Revolution. There is a fictional president of an African country named President Nimbala. He comes to the White House and he says, there are people who make miracles in the world. One of them lives right here in the US. India had been ravaged by drought and overpopulation, but in his hands, the wheat crop increased from 11 million tons to 60 million tons annually. And then know-it-all President Jed Bartlett says, that's right. His name is Norman Borlaug, by the way. He won the Nobel Peace Prize in 1970. And then later that day, President Bartlett's sitting around with his staff and he explains a little bit more about it. He says, did you ever read Paul Ehrlich's book, The Population Bomb? He wrote it in 1968. Excuse me. Ehrlich said it was a fantasy that India would ever feed itself. Then Norman Borlaug comes along. The dwarf wheat, and this is what they called the short-statured wheats that Norman Borlaug bred. The dwarf wheat, guys, it was an agricultural revolution that was credited with saving 1 billion lives. That's legend number one. Legend number two, BT cotton in India. Just a little tiny bit of background here. Genetically engineered crops or genetically modified crops have been around since the mid-90s, but basically there are two technologies that completely dominate the world of GM crops. One of them is HT, that's herbicide tolerant, so that the farmer can spray the field with an herbicide and hopefully kill the weeds, but not the crop. The other one is insect resistance, and this is done by, there's some strange bacterium called BT, and you can take a gene out of it and put it into a crop, and the crop will produce its own insecticide. These two technologies are basically the story of GM crops. 89% of all the GM acres in the world have got HT on them. 99% are either HT or BT or a combination. Only 1% have any other GM trait. So these are the things that dominate so actually there hasn't been that much done with GM crops commercially since they first arrived in the 90s. But it's this BT is the one that a lot of us have thought for a long time might really have some potential for the global South and for peasant farmers. So if you want to talk about the global South and peasant farmers, when it comes to GM crops, you're talking about India, really. This is a chart that shows where GM crops are planted worldwide, mostly in the US, a lot in Brazil and Argentina. That's not peasant farmers, that's not smallholders. Those are big, large scale commercial farms growing herbicide tolerant soybeans for export mostly. Canada grows a lot of canola, which is an oil seed. India is the one country where it's almost all smallholders, peasant farmers, and the one crop that they're planting is BT cotton, genetically modified BT cotton. So India, if you want to talk about the global South and GM crops, India is the most important place. India's got cotton problems. It plants more acres to cotton than any other country in the world, but it's got some of the world's lowest yields. This is a production trend for cotton in India. By the 1990s, there were lots of problems developing in the Indian cotton sector. They were spraying lots of pesticides. The pests were becoming resistant. Farmers were going into debt. And shockingly, they were starting to commit suicide in large numbers. This is the this is an article that I read in 1998 that just blew me away and actually started a whole change in my research direction. I remember this really well. I was on my way, excuse me, I was flying to Australia to give a talk. And I was in Lambert Airport in St. Louis, and I picked up a St. Louis Post-Dispatch, and reading through it, I ran across this article by Bill Lambrick. The headline is slightly misleading. The article's not really about Monsanto, but Monsanto is a St. Louis company, so that's why it got that headline. But the article is about the tragedy of these farmers and spraying enormous amounts of pesticide, pests becoming resistant, going deeper and deeper into debt, and then committing suicide, ironically and tragically, oftentimes by drinking the pesticide themselves. And so the thought was maybe BT cotton would be able to alleviate this problem, because BT cotton has got the built-in insecticide right there in the cotton, and it was being worked on in perhaps for release in India before too long. And the pests that were causing the biggest problems in India were caterpillars, and that's exactly the type of pest that BT is effective against. I started working in India in 2000. BT cotton was released in India in 2002. And here's what happened. The red line shows BT area, that shows the adoption. Started slowly and then went really quickly upward. It's not 100% now, but it climbed up way into the 90s. The vast majority of Indian farmers really quickly adopted BT cotton. The black line here shows what happens to cotton production. This is overall production. And from a low the year before it was released, it just climbed up and up and up. So this has been cited as probably the most dramatic case of peasant farmers adopting GM crops successfully. And there are things in the scientific literature like this yield effects of genetically modified crops appeared in Science, and just lots and lots of stories about what a remarkable success this has been. Okay, so those are the two success stories that I want to peel back the layer a little bit and look at them a little bit more closely. Okay, back to the Green Revolution. Myth number one. People use the term Green Revolution in a variety of ways. I'm using it specifically to refer to wheat and rice bred in the 1960s and adopted mainly in Asia. The wheat was bred in Mexico, a program run by Rockefeller. The rice was bred in the Philippines at the Erie Research Institute. Now, in both places, they were breeding short fertilizer intensive grains. So the two different crops, but a similar trait in them. So the Green Revolution wheats and rices were adopted in many countries, but the biggest splash and the most attention was given to India. India was the country that certainly led the way when it came to wheat. And so that's where we want to focus on. Okay, let me give you the pieces of the Green Revolution myth or the Green Revolution narrative. First, independent India, post-colonial India had Malthusian shortages. Most of you probably recognize Malthus, but for those of you that don't, Robert Malthus was a late 1700s, early 1800s English writer, published a little book in 1798 in London that had an enormous impact on, continues to have an enormous impact on our thinking about food and agriculture. Basically saying, look, population tends to grow inexorably. It tends to grow faster than agriculture ever can. So there's a built-in imbalance, and population is always going to be checked by food shortage. So today we talk about Malthusian shortages as when we don't have enough food and we blame it on the sheer inability of agriculture to keep up with population. So anyway, independent India, they'd had a history of famines when they were a British colony, and then they an independent nation in 1947, and population grew rapidly, and they couldn't keep up in terms of their food production, and they were in a Malthusian, potentially disastrous Malthusian situation. The US sent them large amounts of grain exports, humanitarian grain exports to keep them alive. This chart shows imports from the US into India, the two main food crops of wheat and rice. And you can see that it starts in the 50s and it starts to get higher and higher. And by the mid 60s, there's a hell of a lot of US grain flowing into India. Norman Borlaug, working with the Rockefeller sponsored program in Mexico, was breeding wheat. He bred a series of lines of considered high yielding, and fought desperately to get India to adopt his wheats. He got a lot of pushback, but finally he made some progress there. Then 1966 came along and there was a terrible drought. The drought extended for 2 years. India not infrequently has droughts, but they usually last for 1 year. So this was a 2-year drought. It was a real problem. And the story spread that there were widespread famines going on. During this time, during these years, US exports jumped even higher. This is what happened during the 66-67 drought. Enormous number of ships chugging towards India with grain, and people talked about India living a ship-to-mouth existence. But India started planting the new miracle Borlaug wheats in 1967, so they could be harvested in 1968. 1968 rolled around, the first Green Revolution harvest ended the famine. Wheat production was up 55%, rice up 27%. The famine ended, and after a few years, India was able to stop importing American wheat. And I'm not sure if you can see that or if I'm blocking it, but anyway, this is an article that appeared in the New York Times. It said India has a problem with a problem with a bumper crop. They actually had too much crop coming in for them to store. And here's what happened to the US food shipments during the years following the 1968 harvest. They shrunk down to almost zero by 1972. And very quickly, the narrative developed that 1 billion lives had been saved. The narrative was started by Norman Borlaug himself. I don't think he ever used the number 1 billion lives, but in 1968, immediately after that first harvest, he was off giving speeches and papers talking about the spectacular increases, not only in wheat, but in most other crops. And Borlaug said, scientists, demographers, and political leaders were predicting room for the human race. As late as 1964, I was pessimistic about the ability of the hungry nations of the world to even temporarily solve their food problems. But today, I am optimistic about the outlook of food production in the emerging countries. We have demonstrated the feasibility of shortcuts to increased production if such attempts are properly organized and executed by skillful and courageous scientists. So there is the basic nuts and bolts of the Green Revolution legend. And Norman Borlaug himself went on to make a lot of pronouncements about it. This is him receiving the Nobel Peace Prize in 1970. And he said, we are dealing with two opposing forces, the scientific power of food production and the biologic power of human reproduction. So obviously writing off the whole idea of intensification, the only way that we can keep the Malthusian bear away from the door is by science developing new external inputs to be brought to farmers. And continuing with his Malthusian view of the world, Borlaug said, "I am not one to sit idly by and see man breed himself into a corner by increasing his numbers faster than food production is being increased." So there's the Green Revolution myth. Now, there's been a lot of research in recent years going back and looking more closely at what really happened in India during those years. This is a set of books and dissertations that have all come out in recent years. One of them by Nick Cullither, The Hungry World, a really fascinating book. Cullither is a senior historian, but all the rest of these people are early career historians of science, and a very talented bunch they are. If you don't want to read them all, I don't blame you. I have summarized them for you in this article that appeared in a geography journal last year, commentary, The New Histories of the Green Revolution. So I want to draw on this body of scholarship to go back and take a second look at the Green Revolution. I'm also drawing on research that I've been doing. I've been working on this book, which is now just about done. It's being reviewed, called Buying the Farm. And it's my own take on industrial agriculture. It's bogged down in the review process right now. The press is complaining, oh, it's too long. And I said, I got it down to 700 pages. What do you want? And they want it to get down shorter, but anyway, so it's being reviewed right now. It'll be out one of these days. But I'm drawing on the work of these scholars and my own research to go back and give you a slightly different view of the Green Revolution. Okay, these are the 6 points of the legend. Let's take them one at a time. First, the Malthusian shortages. No. You have to look at what was really going on in terms of economic development in post-colonial India. Gandhi wanted India to develop economically based on self-sufficiency and agriculture and promoting rural life. But he got killed in 1948, and the Prime Minister Nehru wanted to take India in a very different direction. He wanted to prioritize heavy industry, get people moving into the cities, work in factories. Let's have cheap food. Let's not invest in rural India. Let's not invest in agriculture. If we have to import food, we'll import food. And this whole approach was actually encouraged by the US. They also encouraged farmers to grow export crops. So they were growing lots of things like jute, which you may not have heard of, but it's the world's second biggest fiber crop after cotton. They grow lots of it in India. They were growing lots of it in the 1960s. They were make burlap bags out of it and about 100 other things, and they were exporting it. So Cullither points out that as the American scientific establishment geared up to combat India's food crisis, Indian agriculture was quietly experiencing an export boom. So the idea that the agriculture just couldn't keep up with population was completely false. Okay, those humanitarian grain exports, they weren't humanitarian at all. The US during the 1950s had record grain surpluses. And so for political reasons, we started this program, called PL 480 to buy up a lot of the surplus from American farmers. This actually stimulated production even more. And so by 1959, the US was spending $2.7 million a day. And hey, that's 1959 dollars. It would be a hell of a lot more today. They were spending a fortune daily just to store all this grain that they were buying up from farmers to try to keep the farmers afloat. And so what they did with the grain is dumped it onto developing countries. And so India had cheap grain being dumped on it, and this undercut Indian farmers. This has been pointed out by several writers. Here's Perkins. The huge supplies of American grain that flowed into India during the 1950s and the early 60s kept Indian grain prices so low that Indian domestic production stagnated. Indian farmers simply could not compete against grain sold at a loss by the American government, so they stopped trying. Here's Cullither. Economists watched the increase and debated the ultimate effects of PL 480, but one conclusion was clear from the start: cheap grain influenced consumption and production in ways that deepened the dependence on imports. So you think India was importing all this grain because they were so dependent on the US, but actually, in a way, they were dependent on the US because they were importing grain. The grain was making them more dependent. Borlaug and his high yielding wheat seeds, it turns out that the seeds were not inherently high yielding at all. They just responded better to large doses of fertilizer and irrigation. If they didn't get added fertilizer and irrigation, they actually were less productive. So what the Green Revolution, which started in right about here, what it actually led to was India having to use more and more chemical fertilizer per ton of food grain. So just to be clear here, this chart doesn't just show that India used more and more fertilizer. It shows that it used more and more fertilizer per unit of grain. So it just made grain more and more fertilizer intensive to produce. The famine, actually, there was no famine. The Indian leaders reported this at the time. The famine was being claimed largely for political reasons. Demographers have gone back and looked very closely at records from 1966, 67, and cannot find evidence of any increased mortality. It was a tough time, there's no doubt about that. A lot of people were very poor. Food prices skyrocketed and so on, but there was no famine. The Green Revolution ends the famine and imports. Okay, so think about this. The Green Revolution just brought wheat, primarily wheat, into India. Now, India wasn't just short on wheat. India was supposedly short on food. Wheat just happened to be the stuff that we were sending them. Wheat wasn't even the top food crop in India. It wasn't even the second top food crop in India. But India, the problem with India was food, right? And so let's talk about food production in India instead of just what happened with wheat production. This is from my hopefully soon to be published book. This is all with readily available data from the Indian government. These are very solid figures on production. What it shows is that if you throw in the rice and the wheat and the coarse grains, that is all of India's food grains, major food grains, and you look at how the production was growing before that drought, it was growing at this pace right here. Then there was a drought. And after the drought, when the Green Revolution started, it grew at this rate, exactly the same rate. Let me emphasize this. The rate of food production in India did not increase one whit with the Green Revolution. What happened was more resources were transferred over to producing input-intensive wheat and away from producing other crops like rice and like pulses, which are nitrogen fixers and more nutritious than wheat. So what happened was you see the wheat area, the gray area here, getting fatter and fatter, and it's growing at the expense of the rice area and the coarse grains area. So India didn't produce any more food, or the rate of growth of agriculture didn't increase at all. It just started producing more input-intensive wheat. And also, you know, the first year of the Green Revolution, when we had that bumper crop and so on, it's because it was a really good year in terms of rains. So yeah, there was a good year in terms of wheat. There was a really great year in terms of pulses too. In the long run, pulses suffered from the Green Revolution, but boy, that first year, 1968, pulses jumped even more than the miracle Green Revolution wheat. So anyway, I'm talking about input intensiveness. It wasn't just the fertilizer use that went up. It also was pesticide use. So this shows the first Green Revolution harvest here. And until the 90s, when India instituted some new policies to reduce pesticide use just climbed really rapidly. So that's what the Green Revolution really brought. So, finally, in terms of the myth says that it ended the need for those food imports. So this is where our chart was in food imports when we last saw it. Food imports had gone down to almost zero in 1972. What happened after that? They went right back up. The Green Revolution did not end food imports at all. It just led to a brief lull. India still has to import food when it has drought years and there are shortfalls. Okay, so that billion lives saved narrative, I just asked this question. If there was no major famine during the century's worst drought, which was just before the Green Revolution, who were the billion people slated to starve after the rains returned? Who were those people who would have starved? I just don't have a clue. I've gone back through and carefully calculated the number of lives that were saved, and the number is not a billion, it's 0. All right, let's take a look at our second myth to unravel. BT cotton, I've already given you some of the background of this. There has been a really large scientific scholarly literature that's developed all around BT cotton in India. It's been a very closely watched case. There have been dozens of articles, mainly by applied economists, who came into India immediately, even before BT cotton was released, with lots of studies comparing how the BT cotton is doing versus the conventional cotton. The great majority of these articles focus on the first few years of BT cotton in India, and the great majority of them report higher yields, lower pesticide use, better profits for farmers, and in general, positive results across the board for the first few years. There have been a few other people that have reported positive results. The retired Cornell political scientist Ronald Herring has written a whole series of articles talking about the success story of BT cotton. And there's been a lot published in industry-supported forums and so on and so forth about the remarkable success of India. I just want to flag 2 articles here. I'm going to come back to in just a second. One of them is this article, BT cotton sustainability of pesticide reductions in India. And the other one is, why is the failure of BT cotton in India still with us? My critique of this comes largely from an article that I just published with K.R. Kranti. Kranti is, I think, probably, for my money, the leading cotton scientist in India. For a long time, he was head of the Central Institute for Cotton Research, a highly respected, very well published entomologist who is a real expert on BT cotton and Indian agriculture. And he and I published this paper in Nature Plants. It's a major review of long-term data on BT cotton in India. And so here are some of the main takeaways. This is the chart we saw before. And it makes it look like BT cotton was released, it was adopted really quickly, and at exactly the same time, productivity skyrocketed. So it seems to be case closed, a huge success story. But let's zero in on this part of the chart, the part where BT cotton actually is being adopted. The black line shows cotton yields. So this isn't overall production, this is production per acre, this is yield. BT cotton was released in 2002. You can see that it climbed sharply after that and continued climbing, and then it sort of leveled off. Let's compare that trend with actual adoption of BT cotton. The orange area here are official figures for percentage of the cotton area planted to BT. There's also this whole thing about there's some illegal BT cotton planted in Gujarat, which I don't have time to go into it, but anyway, the blue area shows our estimates of how much illegal BT cotton was being planted. So together they show the total amount of BT cotton being planted. So you can see here that yields did rise a lot right after BT cotton came out. In between 2002 and 2005, yields rose 90%. But BT adoption was under 16% at that point. In other words, that 90% rise occurred before BT cotton became popular. it was being planted by a very small number of farmers, way too small to account for a 90% yield rise. Statistically impossible. The years that BT cotton really was being adopted quickly were 2006 to 2010. During the years that farmers really were adopting BT cotton quickly, yields barely rose, only a little tiny bit. They went up, came back down, went up, back down a little bit. So only a very small rise. Then after BT cotton became popular nationwide, yields have been stagnant. So those are the national figures. We also analyzed state by state patterns, and they're really quite striking. There's almost no correspondence at all between yields going up and people adopting BT cotton. Take a look at Andhra Pradesh, where I've worked for the last 20 years. Yields were steadily climbing years before BT cotton came out. They continued to steadily climb for years after BT cotton was adopted. BT cotton was adopted really quickly, right around 2006, 2008. Didn't make any difference at all in the rate of growth. Punjab, similar pattern. Rajasthan, similar pattern. Karnataka, similar pattern. Over and over again, we see that farmers adopted BT cotton in a wave, like they just went in whole hog during just a few years. And during those years, there was basically no change in the growth rate. So what led to the yields going up? It's an interesting question. Well, when I was working in Andhra Pradesh, right in the cotton belt, during the years when BT cotton first came out, 2002, 2003, and the farmers weren't talking about BT cotton. What they were talking about were the new insecticides that had come out. Right in those years, these two insecticides came out that you see in this is from a pesticide shop wall, Tracer and Avant. That's what the farmers were talking about. Two new highly effective insecticides, spinosad and indoxacarb are the active ingredients. Right around the same time, two very important neonicotinoid insecticides came out. So insecticide use surged in India in 2002, 2003, and 2004. So during the years that yields are really jumping, insecticide use was really jumping because of these new insecticides. It's hard to imagine that those yields were caused by BT cotton, which would have led to reduced insecticide use. So insecticides were a major cause of the jump in yields. An even bigger cause was fertilizer. And this is from our Nature Plants paper. You can see that in state after state, the black line is showing fertilizer adoption. The black line is showing increasing yields, and the blue striped area is showing fertilizer adoption. And you can see that fertilizer tracks pretty closely in most cases with increased yields. So why did the yields go up? Insecticides and fertilizer. BT cotton seems to have had very tiny effect. Probably during the years about 2005, 2006, we think BT cotton probably was boosting yields a little bit. But then the bugs became resistant after that, so it didn't last for very long. So finally, I want to make a point. Let's take a look at how the insecticide use worked out. A little bit about the bugs here. BT cotton is only effective against one category of pests, that is caterpillars, or they're called lepidopterans. But there are other pests, especially in India. They're called sucking pests because rather than going in and eating up the bolls or the leaves like lepidopterans do, they suck the sap out of the plant. Okay, so what happened was BT cotton the trait was bred into fertilizer intensive, irrigation intensive hybrid cottons. And so in order to get BT cotton, you had to use these, you had to get the hybrid fertilizer intensive package. The added irrigation and the added fertilizer encouraged populations of sucking pests. And those are the ones that BT is not effective against. So if you go up into 2008, what you see is that sprayings for the lepidopterans, for the caterpillars, were starting to drop in 2005 and 2006. That's when BT cotton was starting to become popular. But we're starting to see problems with spraying for the other ones. One of these major articles claimed is published in 2012, but its data were through 2008, and they claimed that the pesticide reductions were sustainable in India. Let's go ahead and run our analysis through 2018, and we find out that sure enough, spraying for lepidopterans did go down, but it started to come back up because one of the major bollworms, pink bollworm, that's what PBW stands for, pink bollworm became resistant. So they had to start spraying more and more, and it was having less and less impact on the bollworms. Meanwhile, spraying for sucking pests has continued to climb. So I'm not sure if you can see this or if my little box with me and it's blocking it, but right here, we see how much Indian farmers or cotton farmers are now spending on insecticides. It's much more than before BT cotton was even introduced. So let me emphasize that Indian cotton farmers are now spending much more on insecticides than before BT cotton was introduced. The benefits of BT cotton were fleeting and very modest. And now Indian farmers are, their agriculture is more intensive than ever. Okay, so how are we doing on time? So the Green Revolution in India, it was not really a Malthusian problem. The dwarf wheat was not a solution. No lives were saved, and India was left with more input dependence and no more food than they would have had. The gene revolution in India, the BT cotton, the BT technology offered only modest and ephemeral benefits. Indian farmers are left with more input dependence and no more cotton than they would have had otherwise. So Herring asked years ago, why is the failure of BT cotton story still with us? And I asked the opposite question, why is the success of BT cotton story still with us? And why is the billion lives saved by the Green Revolution story still with us? Why indeed? So I turn to the wisdom of the dude here. And I quote, it's like Lenin said, you look for the person who will benefit and, you know what I mean. So the dude was having trouble remembering his course in Marxism in college and so on. But what he was referencing was a famous article by Lenin from 1913, where he said, there is a Latin tag, qui prodest, meaning who stands to gain. When it is not immediately apparent which political or social groups, forces, or alignments advocate certain proposals, measures, etc., one should always ask, who stands to gain? So we can take the qui prodest approach to get some insights into why these narratives live on. Why does the narrative live on with BT cotton? Qui prodest, who benefits? Well, obviously the biotech industry benefits. And they have promoted this narrative relentlessly, not only directly, but through their surrogates. And they've got a lot of people that are actually on their payroll, but are not recognized as being on their payroll, that like to tell the story of the success of GM crops, especially BT cotton in India. But they're not the only ones that benefit. All those articles that I cited from the applied economists, these were many, many career-enhancing, peer-reviewed publications that came pouring out, monitoring the progress of BT cotton, based almost entirely on short-term studies that were essentially meaningless. They just looked at BT cotton in the first place, just on the first few years that it was being used. So they didn't get those long-term dynamics that we saw with the pesticide patterns. And also they were looking at India during a time when very few farmers were even growing BT cotton. So they had a biased sample that they were looking at. So there are various people that benefit from the narrative, and those are some of the beneficiaries. How about the other narrative? Well, the whole Green Revolution narrative starts off with these ideas from Malthus, which I would argue, and many other scholars I think would agree with this, have never really fit the data very well at all. Agricultural shortfalls have never been a major check on human population. And agriculture has grown much more rapidly than population ever since Malthus wrote that book in 1798. Since 1798, world agriculture is up about tenfold, world population is up about sixfold. And that's with us paying farmers lots of money not to grow so much. But Malthus gained traction because of who benefited from his theory. His theory was a delight to the people who owned the factories of the Green Revolution, where people were literally working themselves to death, because along came a theorist saying, if these people are dying, if they're really sick, it's the fault of nature, it's not the fault of the working conditions in the factories. Malthus's theory was very friendly to the colonial empire of England, so that when there was a huge potato famine, a huge famine in Ireland in the 1840s, they could say, well, it's because the Irish are overproducing, when in fact the Irish were exporting food hand over fist to England throughout the whole potato famine. It wasn't an agricultural famine at all. It was a famine caused by poverty and by the conditions of land ownership in Ireland. But anyway, Malthus was very beneficial during the Industrial Revolution and during colonialism. So those are some beneficiaries there. We get around to the Green Revolution itself, and the whole story has been enormously helpful to US Cold War geopolitical interests. The whole phrase Green Revolution was invented by an AID administrator, William Goud, so it's sometimes called an act of God that it was called this. But he was the one in 1968 that coined the term. There was a Green Revolution going on, and he explicitly contrasted that to the Red Revolution of the Soviets. So the US was very interested in trying to provide food to tamp down communist insurgencies throughout Asia. Other beneficiaries, obviously agricultural capital, a tremendous amount of money to be made by, by selling inputs to people in the developing world. And this story is very favorable to that enterprise. Very beneficial to Borlaug himself, having self-declared, after talking about the skillful and courageous scientists, he was the main one of them. So I think it's fair to say he was a self-declared skillful and courageous scientist. He won a Nobel Prize, despite the fact that, as the data show pretty clearly, it didn't make any more food for India. And then finally, the other beneficiary of the Green Revolution myth is biotech capital. So here, the Green Revolution myth and the BT cotton in India, or the gene revolution, flow together. Late in his life, Norm Borlaug was visited by the chief technology officer at Monsanto, my friend Rob Fraley. And as Rob later reported it, he said, you could see his eyes were starting to well up. And I said, Norm, what's wrong? And he said, Rob, I've made it all the way through the Green Revolution. I don't think I'm going to make it through the Gene Revolution. So it's linking the GM crops to the Green Revolution story is very important for the biotech industry. And the last thing I want to do is just very briefly give you a very brief history of biotech debates to explain why that is. GM crops first appeared in 1994. There was very little backlash. In 1996, backlash started in Europe. And by the late 90s, the biotech industry realized that it needed to have a compelling narrative to sort of fight off the opposition that was growing to it. And so in the late 90s, the biotech industry started this narrative that GM crops are really for the developing world. And you have articles here about how GM crops are needed for the hungry. GM crops are needed for the poor. GM crops are needed for smallholders in the global south. So that was a narrative that was being pushed. The problem is there weren't any particularly good crops for the hungry, the poor, or the smallholders. And there have been a lot that have been discussed, and we don't have time to go through these, but golden rice was discussed much. It's still not ready to go after several decades. Biofortified cassava, I wrote about this one back in 2002. I thought this was really promising for the developing world. Here it is 2020, still not ready to be released to farmers. Virus-resistant cassava, I thought this had a lot of potential for farmers in the developing world. Over 20 years in development, still not ready. BT cotton in South Africa, Zulu smallholder farmers were planting BT cotton for a while, and it looked like it was going to be a success. It turns out they were only planting it because the company was giving them credit to plant it, and they stopped after a while. BT cotton in Burkina Faso, this was supposedly a major success story, but they stopped planting it after a few years. So the biotech industry really needed success stories. Nothing seemed to be working out. And that brings us back to BT cotton, very large scale planting by farmers in the developing world, apparently a dramatic success. And so it has been very important to promote this. So it's likened, this allows them to liken it to the Green Revolution. So the Green Revolution myth is still with us, in part because of the need to keep the BT cotton myth with us. Okay, so that is what I wanted to talk to you about. I wanted to thank my funders, the National Science Foundation, the John Templeton Foundation, the Winogrand Foundation, and the John Guggenheim Foundation. And I wanted to thank the Cohen brothers for making us laugh. And so I'll end there and I'll say thank you.
Thank you very much, Dr. Stone. And now we'll have a short Q&A session. And I wanted to encourage folks to continue to submit their questions in the Q&A. You can type it right inside the chat box next to this YouTube video, and Dr. Stone will answer your question. Why do industrialization projects with agriculture tend to fail? What's the solution for that?
Well, there's two questions. Why they tend to fail, I think there are several parts to it. I think the first part is a complete misunderstanding of how agriculture develops, about how agriculture works in the developing world. That's the first part. The second part is that the people that actually design and run these programs, it's not always clear that they're, excuse me, it's not always clear that their interests are aligned with leaving a sustainable project. Oftentimes they're designed and run by people who are engineers and short-term agriculture experts who are sort of in the area for a while to get something up and running. And once it's up and running, they leave and it frequently falls apart, and they can then say, well, I did my part, and they blame it on the Africans once they're gone. Another major reason is that most industrial agricultural technologies require subsidy from the government. And so developing hybrid seeds, developing fertilizers, developing tractors, developing GMOs was all done with very large subsidies from the government. And so most developing countries don't have that sort of economic muscle. They can't afford to develop these technologies. And if they can't afford to develop them, it's often hard to keep them going. So that's why those are some of the reasons that a lot of the projects, industrial agriculture projects, fail. In terms of what's the solution, I don't know. It depends on the solution to what. My business is doing research to understand how these agricultural systems work. And so to me, the first part of the solution is to go into areas where peasants are farming and say, well, what's really happening here? Let's not just assume that because they're not using fertilizers and tractors that they're woebegone and they're starving and so on and so forth. And frequently, if you go in and you take a close look at people, you find out that their farming actually is working quite well. We found this out. We did extensive work with this group in Nigeria called the Coffeear. And that photograph that I showed earlier is during part of our Coffeear research. And the Coffeear were farming very sustainably, very productively, and producing a surplus for market. But when I talked with the agricultural development officials down the road, they just didn't believe it. They said, oh, we need to get those people some some fertilizer and some tractors. And I said, well, have you been down there to see what they're doing? They say, no, but the assumption is that that they need external technology. So the first step, I think, is to really take a look and see what's going on.
Okay, great. Thank you. Our next question comes from a viewer who, first of all, thanks you for the great talk, and also ask why BT cotton seeds sales are still high. Is it subsidized, or what's the story with that?
BT cotton seeds sales are high because the conventional seeds have largely disappeared from the market. They've largely disappeared. And also the BT still, it offers at least some protection against one bollworm. There are a whole bunch of different lepidopterans, but there are two that have become really major problems in India. One of them is called the American bollworm. It's not actually American, but it's called that. And the other is a pink bollworm. And BT continues to control the American bollworm. So that is something of a plus. The pink bollworm is even worse, and it is no longer controlled. So I think they plant it partly because it still gives them at least benefit against that one bollworm. But the main reason is that the conventional seeds have disappeared.
Great, thank you. The next question, kind of on the flip side, have you found in your fieldwork a case where GMOs or agricultural technology has benefited the lives of a small farmer or any particular group?
I don't know of a good case for small farmers. Now, GM crops have had some benefits with large farmers. There's no doubt about that. Talk about BT cotton, it's had enormous benefits in southwestern US among large commercial farmers there. It not only has reduced predations by the pink bollworm, in many areas it's actually eradicated the bollworm. So that's great. It seems to have worked just fine for them. There are added costs to them to buy the BT seeds, but they save money on pesticides. So I think it's not just a net gain in terms of getting rid of the bugs. It's a net gain in terms of productivity and in terms of the economics. In terms of smallholders, I don't know of any particularly good cases. I'm still hopeful. There's one possibility that I am following and colleagues who work in Africa are following, and that is that in Uganda, the staple starch there is a kind of banana. We don't grow it in the US. It's called a matoke banana. It's not like the big sweet banana. It's a smaller starchy banana, and it's their staple. And it's beset with all sorts of problems. There are not only pests, but viruses and bacterial diseases. And they're working very hard to create a genetically modified matoke banana that will hopefully be resistant not only to pests, but to the bacterial and the viral diseases. And so I'm hopeful about that one. But then I've been hopeful about other ones before. I first went to India because I thought this was the case that where the GM crops would really be helping the farmers. Because of that whole lead up to that I showed in the slide, they had terrible problems. The biggest single pest they had was the American bollworm. BT cotton looked like it was going to control the American bollworm, and I thought that the story was going to be a lot of GM crops have not been very beneficial to smallholders, but this is the case where they really have. And for a while there were some slight gains, but as I've said, in the long term, there weren't. So anyway, I've been hopeful before. I was hopeful about the genetically modified cassava as well, and I wrote about this. And I actually took issue with some of the green critics who I felt were knee-jerk and too quick to say, anything GMO has got to be bad for smallholders. My argument was, well, no, let's keep an eye on some of these things. Let's keep an eye on golden rice. It does have promise. Let's keep an eye on genetically modified cassava. So I've been disappointed with all these. So anyway, I wish I could say yes, but the best I can say is, I don't know, maybe the cassava will be out in a few years and it will be helpful. Maybe the banana will be out in a few years and it will be helpful.
Thank you. Our next question is, what have been the costs for Indian farmers who have not only had to access BT seeds, but all the fertilizers and other inputs that you discuss?
Well, costs have gone up for Indian farmers. There's no doubt about it. They've had increased costs for fertilizers. They have had increased costs for the BT seeds. As the charts show, they've had increased costs for insecticide use. And what I didn't even talk about, but they've also had increased labor costs. That's probably for good reasons. There was a law passed that made them pay agricultural workers more, which is a good thing, I think, because agricultural workers were paid just scandalously low wages. But anyway, the net effect of all this is that the costs of being an Indian cotton farmer has just gone up and up, and more money is going out of their pockets into the pockets of input producers. It's still really hard for them to get by. And one of the ways that the Indian government has raised what they call the minimum support price paid for cotton. So in effect, they're being subsidized a bit now, like American farmers are really heavily. They're being subsidized a bit in order to keep them afloat. But the costs have been quite serious.
Thank you. Our next viewer question asks if the fertilizer increase during BT cotton adoption, what was driving this? They say that they understand insecticides because they were a newer product, but wanted to ask about fertilizer.
The main thing that drove the fertilizer use was that they were adopting more and more BT cotton, which was in fertilizer intensive hybrids. So people have to separate out the things. I mean, you're adopting a new crop, and it's not just life as before, except now it's got a BT trait and it'll kill the caterpillars. It's also that BT trait has been bred into hybrids that are specifically bred to be fertilizer intensive. And so when you start planting more and more of these hybrids, you have to start using more and more fertilizer. Also, there's an addictive quality to it. You have to give more and more fertilizer. The soil starts to require more and more fertilizer to get the same impact. So it's the first part of it is just adopting the hybrids. And then the second part is continuing to plant the hybrids and getting that addictive quality.
Thank you. Our next question is if similar crashes in BT's cotton's effectiveness has happened here in the US.
The cases I follow in the US, I would say no. The one I was talking about a minute ago, which was that in the Southwest, it has continued to be quite effective. To the best of my knowledge, I have to caveat this, but to the best of my knowledge, none of the BT cotton used in the US has run into these sorts of problems. They've been following it really closely to see if there is what they call field-derived resistance. That is, by planting this stuff, you put selective pressure on the pests to develop resistance to it. That has been a problem in some other places. That's a problem they have in India. It's been either zero or a very, very minor problem in the US. But that's BT cotton. Other GM crops in the US have had enormous problems. The most widely planted GM crop in the world by far is herbicide tolerant soybean. And they have got really terrible problems with resistant weeds. The weeds become resistant to the herbicide. So there's that problem. Actually, with cotton, let me backtrack a minute. Actually, there is a problem with herbicide resistant weeds in cotton. So there's, in particular in the Southeast, there is a weed in cotton called Palmer amaranth that has become very resistant to herbicide sprays. And so this is from the herbicide tolerant trait in cotton. But you have cotton farms now in some places of the Southeast where they have to go out and take a chainsaw to cut down these big hardy Palmer amaranth plants. So the BT problem hasn't been a problem, but the BT resistance to BT hasn't been a problem. But what has been a problem is this other trait in genetically modified cotton, that is herbicide tolerance.
Thank you very much. The next question is, GMOs are incredibly expensive to develop. Have you looked at opportunity cost in terms of what could have been accomplished with that money otherwise?
That's a great question. I can't put any numbers on it. But first, let me just say something about, hybrid corn came along. It was developed mainly by public breeders during the teens and 20s. And it was released in the late 20s and 1930s, and it gradually shoved out most other conventional corn. And so the non-hybrid corn, which is called open pollinated corn, got to be very rare, and it's just grown by people for little niche markets now. And if you draw a chart of how corn yields have gone up, they've gone up and up and up. There's no doubt about it. But a famous breeder pointed out several years ago that they probably would have gone up just as much if we had put all that effort into open pollinated corn. So in other words, it all depends on what you compare things to. If you see yields going up, it's silly just to say, well, that's obviously good, because the question always is, what would have happened to the yields if you'd had a different technology? So that's been the story with hybrid corn. I strongly suspect we would have yields just as high if we'd never gone into hybrid corn. I think you could probably say similar sorts of things with GMOs. The viewer is absolutely correct that enormous amounts of money have been poured into developing GM technologies. And if that money had been poured into developing all sorts of other things like conventional breeding of crops, there definitely would have been major advances. What those advances would have been, it's just, we can only speculate. It's a hypothetical. But I just want to underscore that question. That's the sort of question people need to be asking. And when somebody says, look at the benefits of GM crops, the question always has to be, yeah, but what would the benefits have been otherwise? One other thing that I should add to that, several years ago, the National Academy of Sciences convened an expert panel to try to summarize what do we know about GM crops in North America anyway to date. And it was a very high level expert panel. There were lots of major biotech supporters on it. And they produced a big report that came out in 2016, and it's available online. And one of their big findings was that there is no evidence that GM crops have increased the rate of agricultural growth. In other words, it's true that since the 90s, when GM crops have been adopted, productivity has gone up, but it's gone up at the same rate it was going up before. So again, you always have to compare. You have to compare what you have seen with what might have happened otherwise.
Okay, and for one last question, you mentioned that BT cotton was grown illegally. How and why?
It's an interesting story. They were working on Monsanto and their Indian partner, which is the Myco company. In the early 2000s, we're working on developing BT cottons, breeding the trait into cottons that grow in India. So the laboratories had seeds that had the BT trait in them. It appears, I can't prove this, but I think most people think it's what happened. It appears that somebody stole some of those seeds, and they found their way into the hands of a breeder in Gujarat who had a company called the Navbharat company, and they bred them into some really good cotton. And so they were not advertised as BT. They couldn't be sold as BT because BT still hadn't been approved by the Indian government. There's a committee that has to approve genetically modified crops, and they hadn't approved it yet. So they couldn't sell it as BT. But the trait was put into some really good, it was called Navbharat 151. It's a famous breed of cotton. It's legendary, and farmers planted it, and they found out that it killed the caterpillars for some mystical reason. And it was highly productive, and it spread quickly in Gujarat. And then somebody went into the field and did some snippings and did some tests on it, and they found out, they said, this is BT cotton, this is BT. And the Navbharat company said, no, we don't know anything about this. No, it's clearly BT. And so the government threatened to, the government shut them down. They said, you have to stop selling this. The government threatened to go in and destroy all the illegal BT that was growing in the farmers' fields. but they never did it because it would have been highly unpopular. And so it was the year after that legal BT appeared. But there was still some of the illegal stuff being washing around, and farmers were actually breeding some of their own cotton for a while. But then after a while, there was no point in them doing it because there was plenty of BT in the stores and so on. So there's been a lot written on this. I wrote an article on this as well. The whole story of illegal Navbarat 151 is an interesting one.
Well, thank you for sharing. And with that, that concludes tonight's presentation. Thank you again, Dr. Stone.
Thanks so much. It's been my pleasure.